Hello and a very good day. My name is Abhilash and I am from the AD Solutions or the Active Directory Solutions team here at Manage Engine, and I would be your presenter for today. Now, before we go ahead and jump into today's webinar, I would like to thank you all for joining in. I hope all of you are safe and all of you are indoors. Now, I understand that these are extremely troubled times, and I would like to thank each and every one of you for joining in today. Thank you so much for your time, and thank you so much for giving us an opportunity. Now, before I go ahead and jump into today's webinar and show you what's in store for us, I would like to run a quick audio and video check. Now, the reason I want to do that is because I want to make sure that everybody out here today, each and every one of you are able to hear me and are able to see the screen well, right? So I'll quickly start off with an audio check. If you can hear my voice, if my voice is well and audible, just use the chat box that you see in front of you to give me a confirmation. Just say yes, just say okay, just say great, so I can confirm that my voice is reaching to you well and clear. Thank you so much, Pradeep. Thank you so much, Rajendra. Thank you so much, Atul, Mustafa. Thank you so much. Now, if you can see the screen, the title, that's IT Security, PowerShell as a Cyber Attack Tool, and my email ID, just give me another confirmation. Just a visual confirmation, a video confirmation. Perfect. Thank you so much, Pradeep. Thank you so much, Mustafa. All right. Now, before we jump into today's webinar, I would like to tell you that the entire session today is being recorded, and the recording would reach to you on your email post the webinar. So if you've got any questions, use the Q&A tab that you see in front of you and punch in your questions, and I will take them towards the end of the webinar. And even if I miss taking your questions, or you have questions or queries later in the day post the webinar, you can always drop an email to me at abi@manageengine.com. That's abi@manageengine.com. Just drop me an email and I'd be more than happy to help you out. But until then, we've got the Q&A tab. All right, perfect. Without further ado, today's webinar's topic is PowerShell as a cyber attack tool. Right now, why did I choose to speak about this topic today? And why am I talking about PowerShell in specific? Now, the whole reason I chose to speak about this topic today is to shed light on an important factor when it comes to cyber attacks or security attacks. Right? So whenever I utter the term cyber attack or security attack or a data breach, we always think of an attacker trying to smuggle in malicious tools, malicious softwares via a pen drive, or maybe an attacker is downloading third-party tools from the internet that will help him or her crack passwords. We may also think of ransomware. The list simply goes on, right? But the one important thing that we tend to forget when it comes to security breaches or cyber attacks is that tools and features that are built into our system, that are an inherent part of our operating system, can be leveraged in attacks. Tools such as command prompt, tools such as your Windows registry. And in this case, PowerShell is a classic example. Right? Now, what is PowerShell? I'm pretty sure most of you would have used PowerShell, the big blue screen that you see right here, right? I'm pretty sure most of you would have used the screen to either configure something, to set up a service account, set up an application, set up your cloud instance if you have one, or simply query information from your domain, right? This tool right here, this big blue tool, was introduced by Microsoft to help administrators automate their tasks. Right, to automate tasks, to set up schedulers, to query for information. So the whole point I'm trying to put forth here is that PowerShell is a secure administrator whitelisted tool, right? And PowerShell is now increasingly being exploited by attackers. Now, let's take a quick look at today's agenda. We'll take a look at the attack landscape of 2020, and we will see the most prevalent attack these days. Right now, these attacks started off back late in 2019 and now into 2020, and these attacks are called malware-free or fileless attacks. Right? In the second part for today's webinar, we'll take a look at a few attacks that have happened around the world a few live examples of malware-free attacks. And then we'll see why attackers are going malware-free. And we'll see why PowerShell is a favorite weapon of choice for attackers, right? Especially to perform malware-free or fileless attacks. The fourth part of today's webinar will take a look at the PowerShell cyber kill chain and a demonstration of a few PowerShell-based attacks. And last but not the least, we will see how Manage Engine can help you protect your organization from PowerShell attacks. Right? We're gonna go through the entire journey, right from basics as to how PowerShell is used, how it could be abused, how it could be exploited, and finally, how you could protect your organization, how you could safeguard your employees, your organization sensitive data from PowerShell-based attacks. So the attack landscape of 2020, rise of malware-free attacks. Right now, malware-free attacks are essentially attacks that are script-based. Right now, as you must know, PowerShell and command prompt can be used to run scripts, right? And they are administrative tools. So essentially, they have access to the core parts of your operating system, right? So all an attacker has to do now is to create a script, which takes a few minutes, right? Or Google, download a script from the internet, run it using a built-in tool such as PowerShell, and that's it. Right? So that is the whole concept of script-based or fileless malware. Such attacks are not dependent on end users downloading malware from the internet, from the dark web, or inserting malware from a USB stick or an external driver. Most attacks these days, most attacks in 2020 are executed by piggybacking on legitimate software packages, right? Software packages like PowerShell, like Windows Registry, or your Microsoft Excel or Word document. That's how malware enters your organization. And more attack patterns that are being observed use tools, use features, use options that are built into your operating system, that come pre-installed or that come default with your operating system. More than 60% of today's attacks involve fileless techniques. Again, using existing software, using organization authorized applications, and using authorized Windows protocols to carry out malicious activities. Right, so that's the whole concept of malware-free attacks. There's no downloading involved, no inserting pen drives, no downloading tools from third-party websites or the internet. Just create a script, leverage a tool that is built into your system, and that's it. That's the whole game of attackers these days. Now, here are a few examples of recent fileless attacks or malware-free attack trends, right? These attacks happened between April and June 2020. Number one is the San Francisco airport hack. How did this happen, right? Attackers basically installed a piece of code, just 4 to 5 lines of code on each victim's Internet Explorer browser, and those credentials were collected by the attacker on his or her system, right? So essentially, attacker had a network sniffer installed on his system, and attacker managed to somehow get the code on the victim user's browsers, Internet Explorer browsers. And once the victim opened the browser, the victim's credentials or the password hashes were pushed to the attacker's system. Why? Because there was a network sniffer installed on the attacker's system. We'll get into the details of the San Francisco attack later in today's webinar. Right? Number two, the classic COVID-themed attacks. Attackers always leverage the pain points, right? Things that are going wrong in today's world. And now it's the pandemic, right? You might be browsing the internet and you may get a pop-up saying, hey, your Flash player is out of date. Your Adobe Flash player is out of date. Please update it. So what do? You click on it. And when you click on it, little do you know that there is a malware, right, that is being installed in your Windows system, right? That is being probably set up in your registry that you are not unaware of. And every time you log in, that piece of code or that malware will be executed. Number three is the Tycoon ransomware. Now, what is the Tycoon ransomware? The Tycoon ransomware came at around June or July, I believe, and this ransomware leveraged the Java component, right? The Java runtime environment, or the JRE, and the JDK. So the whole point I'm trying to put forth here is that the way attacks are being performed these days are completely changing, are completely evolving, right? Attackers are using built-in features into the system. For example, the browser, for example, Java runtime or PowerShell, right? The core binding factors for all the attacks that have happened in the last 2 to 3 months is that attackers used default pre-installed system tools and legitimate software. Now, why do attackers prefer malware-free attacks? Why is this a go-to option for attackers? Number one, these assets are widespread in enterprises. They are pervasive in enterprises. Now, what do I mean, right? For example, let's just take PowerShell. PowerShell is built into every Windows system right from Windows 7. That's right, your Windows 7, your 8, your 10, your Windows Server machines, every system has a PowerShell console that comes pre-installed. So attackers have no work to do. Once they have access to the system, they can use PowerShell to gain further access or privilege escalation, right? Or gain access to organization sensitive data. Number two is that non-malware intrusions typically go undetected by antiviruses. This is a very big problem because most antiviruses are equipped to deal with third-party ransomware. For instance, if you download, let's say, a malicious tool from the internet, your antivirus can potentially track it, flag it, and even block it, right? Antiviruses are capable of detecting foreign substances that are downloaded from the web or from the internet, but antiviruses are not capable of detecting scripts on your system, right? So if I potentially create a script to conduct a password attack, to conduct a password spree attack, my anti-malware tool or my antivirus solution might not be able to detect it. That's a good probability because why? It's just a few lines of code, right? And it is a PowerShell script. So a PowerShell is essentially an administrator's whitelisted, authorized, and a secure tool. Number three, scripts are not that hard to create. All you need is some knowledge, or you could simply just Google the script that you want and you can download it, run it with PowerShell, and you're good to go, right? And because such tactics exploit legitimate applications, tools, and options in your operating system, whitelisting tools fail, right? Because you would not block command prompt in your organization. You would not block PowerShell in your organization. You would not block the Windows registry in your organization. These are applications that need to be running in your organization for your systems to function properly, right? You cannot block pre-installed tools that come built in with your system, right? So these tools are typically whitelisted in most organizations. They are not blacklisted, which again brings me back to my point. They are readily available for attackers to use them. Now, why is PowerShell a favorite choice, right? We started off with the concept of script-based attacks and malware-free attacks where attackers are leveraging tools and features built into the system, right? Where attackers are not downloading tools from the internet anymore. Tools such as command prompts, such as PowerShell, such as the Windows registry, or even the control panel for that matter. But why is PowerShell a go-to choice? Number one, PowerShell is an administrator's tool. PowerShell was created by Microsoft to help administrators automate tasks, to help administrators configure the critical parts of their operating system or even cloud services for that matter, to help administrators query sensitive data from their organization's domain, right? So PowerShell essentially has unprecedented access to all core system parts and restricted APIs. Most PowerShell attacks run in memory. That's another concept of malware-free attacks or fileless attacks, like I call it. Now, when you have a PowerShell script, right, you can have it on your hard disk. That's option number one. Or you could simply get it off the internet. All you have to do is simply open up PowerShell console, download the script from the console without having to paste anything on your hard disk, and run the script in memory, that is in your volatile memory or your RAM. This way, nothing is dropped to the hard disk. And even if your antivirus solution or anti-malware solutions can detect the script on your system, that would be a fail because you are running scripts in memory. You are running scripts in your RAM. right? PowerShell, like I said, is a whitelisted secure tool, has a trusted signature that is trusted by most antiviruses and most parts of the operating system. PowerShell is an administrator's tool, right? So essentially, it's pretty easy to obtain elevated access, right? All you have to do is click on PowerShell and try to obtain elevated access. Right click, run as administrator, and you are good to go. PowerShell has the ability to run remotely. That's right. PowerShell is used by administrators to monitor every member server in the organization, every member server, every workstation, every file server. The capabilities of PowerShell are limitless, right? Because essentially it's an administrator's tool. It's supposed to do all of that. And last but not the least, there are free tools, free scripts available online with instructions of how to run them. All you have to do is simply download, follow the instructions, and you've got an attack guidebook right on Google, right on the internet, right? And 95% PowerShell scripts that are found in the wild are malicious. This is semantics research, right? That happened back in 2019 or the later part of 2019. Now, PowerShell essentially satisfies every phase of the cyber kill chain. Now, I see a few questions coming in. Please hold on and I will get back to you with the answers as soon as the webinar is done. All right. So PowerShell satisfies every phase of the kill chain, right from reconnaissance, right from finding out information, right? And number two is weaponization, creating a tool that can basically cause an initial infection. Number three, delivering the weapon, delivering the weaponized macro or script that you created to end user system. Number four, executing the delivered malicious piece of code or malicious piece of script. Number five, installation, installing malware onto the system, right? And essentially gain hands on all the critical parts of your operating system. Now, this may feel like a lot of information, but let's just take a look at a few quick demos, right? Number one is reconnaissance and domain surveillance with PowerShell. With PowerShell, you can query all critical parts of your organization's infrastructure, right? And the best part here is to run these commands, you do not need administrative privileges. You can be a standard non-privileged user and you can obtain information about the critical parts of your operating system. So let me quickly show you an example right here. If I head to my VM right here and minimize this, and let me just open up PowerShell, right? Here we go. Let me increase the size so you can view this a little better. You can now see that I'm logged in as a user called Ross. I've just opened up a PowerShell session. Now all I have to do is run a command called net user Ross, right? These are Ross's group memberships. So all I'm trying to say here is that Ross is a non-privileged user just logging on to his domain joint system, to his workstation, and has PowerShell and of course some internet to do his or her job. Right now, how would I find out information? Right? So I am an insider, just a part of an organization who wants to find out critical information about the organization's infrastructure. This is how I do it. All I have to do is run a command. Let's just say get AD default domain password policy. And once I click enter, I have the password policy of the domain, right? The minimum length of the password, the minimum password length. When will an account get locked out, right? The number of limits I have to lock out an account, right? The lockout observation window. When will an account's lockout threshold be reset to 0, right? Information such as this can be found. Now, let me quickly run another command called, let's just say get AD user, right? Pretty straightforward. And I'm just going to say everything. And here we go. We have all the users in the organization and their respective email IDs, right? Pretty straightforward. So here I have the user's name. Here I have the domain's name as well, right? So all you have to do is combine the username and the domain name, and you have the user's email ID, right? And I can go further down and essentially, let me clear this. Try and get group memberships. Let's just say get 80 group. Let's just call it the administrators group, right? And this will give me members of all the administrators group in my domain, right? So it's pretty straightforward. All I have to do is simply run a command, get 80 group member, identity, and let's just say administrators, right? And here I have all the members of my administrators group in Active Directory. Right now, there are again free tools online that can help you expedite this process. For instance, here is a tool, right, that can potentially push out all your critical domain information in the form of CSV files, like you can see I have done here. Right? For instance, if I quickly open up, let's say, domain enterprise admins, here I have all the names of my users who are enterprise admins of the domain. Right? So I don't have to manually open PowerShell and run one command after the other. I can simply use a tool that will automate the entire process for me. Right? So this is reconnaissance as an internal user. We're assuming that the attacker has already compromised the initial access and got access to any user system in the organization, or the insider or the internal user of the organization wants to have some fun or has turned rogue. Right? So that's the assumption. How do we do reconnaissance when it comes to an external attacker? When it comes to an attacker who's got no access whatsoever on the organization's network? Now, there are many ways an attacker from outside the domain can perform reconnaissance. Right? There are free tools. Again, as you can see, I have a tool here called Multigo that can help you find out any domain's email addresses. Right? So here you have the domain. Let's just say, I'm just going to call the domain Microsoft.com. Right? And I'm going to right click on it, and then I'm just going to say email, right? So 2 email addresses, and just within a few seconds, I have potential email addresses belonging to the Microsoft.com domain, right? So I click 2 email addresses. All right, looks like my tool, here we go. So these are potential email addresses that belong to the Microsoft domain. Right? There are many tools that you could use like this. For instance, there is a tool called the email permutator that you can potentially use. So all you have to do is simply Google, go on LinkedIn, go on Facebook, get the user's name from the organization, run it through the permutator tool, and you will have a potential list of valid email addresses. Right? So there are a number of ways you can perform reconnaissance as an external attacker, and at least, if not critical information, you can get the email addresses of the users that are working in the organization. As an internal user, the capabilities are limitless. As an external user, you can at the least get the email addresses, right? Now, the next step is weaponization and delivery, right? As you can see, the first step of the cyber kill chain was reconnaissance. Now, the second step and the third step is weaponization and delivery. So how do we go about doing that? So as an external user, how could I weaponize or create a weapon using PowerShell, right? So this is how I do it. All I have to do is simply open up PowerShell, right? And let me quickly close this. Open up my system right here, head into this PC, Windows, and System 32. And you can see that I have a script here called Lucky Strike, right? This is a script that I, again, got it from the internet. It's pretty straightforward. So all you have to do is simply right click on the script, properties, security, copy the path of the script, right? This is how you can run a PowerShell script. I will open up PowerShell on my system. This is my workstation. I'm just opening it up as an administrator, who's just me, right? And now I'll quickly paste the path of the script. Right now, The command I need to run is PowerShell.exe-exec and then bypass. Now, the reason I'm running this command is because PowerShell by default does not let you run scripts that are not digitally signed or that are not from legitimate sources, right? So this command will enable me as an end user with no privileges to run any script that I want, right? Any script. So with that done, I'll quickly import module./luckystrike.ps1. Right? This is just a PowerShell script, nothing fancy happening here. Now, watch closely. All right. Now, I will create a catalog, and number one option is to add a payload to a catalog. Right? I'm just going to call it calc. Please watch what I'm doing because I can explain what's happening later on. And number one is now. What I'm trying to do here is I am trying to create an Excel file or a Microsoft Word document with malicious data in it, right? So it could be a command, it could be a PowerShell script, it could be a malicious executable like mimikatz.exe. Now, just for example's sake, let's just call it a shell command. I'm just going to call it one. The text is going to be calc.exe, right? So the payload, as you can see, is added. I'm just going to head back. Number one, payload options. Number one, select a payload. I want it to be an Excel document, and it's going to be the calculator application, right? Infection method, I'm just going to call it the shell command. As you can see that the payload is now added. I'm just going to head back again. And now I will generate a new file, right? Number one, generating a new file, generating macro code. And you can see that I have created an infected Excel sheet. So if I head into my system right here and payloads, I have an infected Excel sheet right here. What's the name of the Excel sheet? It's this, right? So when I open the Excel sheet, this is what's going to happen, right? Oops, looks like my system hung. All right, so what's going to happen here is when I try to open the Excel sheet, it's going to ask me to enable macros, right? So in order to read what's in the document, you'll have to enable macros is a pop-up that I would get. And once I enable the macros, all right, it's open, good for us. Let's take a look at what happened. Right, so it's open, macros have been disabled. As an end user who doesn't know much about PowerShell attacks, I'm just going to click enable content. And you can now see that the calculated application has launched. Right, now the information I'm trying to put forth here is that any script, any PowerShell script, or any executable can be added to an Excel or a Word document. Now you can see that I've added a calculator because if I potentially run a PowerShell script on my system, I would get a call from my administrator. So here you can see that I have another option called a pass attack. This is potentially a password spray attack that I could add to the Excel document, right? Or a Word document. So this is a script using PowerShell. I am able to generate malicious document macros. Could be an Excel, could be a Word macro as well, right? And what do we do with the macro? Remember that we are trying to run this attack as an external user, right? So what do? I just take the macro and I send it as a spear phishing email. Hey, do you want to know who are the people in your locality who are infected with COVID-19? Click here, download this attachment. Here's what WHO is not telling you about the COVID-19 pandemic. Simply download the attachment to find out more. End users love to click, right? So they download it, they enable the macro, and what happens next? Malware is installed onto the system in the form of a PowerShell script, right? And this script is not monitored by antiviruses because PowerShell is a legitimate system tool, right? As an external user, This is how I could bypass the initial infection phase. How could I bypass the initial infection phase as an internal user? The process gets a lot more easier. Let me quickly show you. If I head on to my VM right here, you can see that I have a script called the domain password spray. Again, freely available over the internet. It takes a few minutes to create it. And let me show you what it does. Right, so I will open up the PowerShell console as Ross. I'm going to head to the desktop, as you can see, and run the command again to bypass the execution policies and run any script that I want. Import a module and call it /domain password spray, the module that you see right here, right? .ps1. And now invoke domain password spray. Let's just give in a very predictable password, right? Passwords that is typically used in most organizations. Let's just call it password at 123. And once I click enter, you can now see that the spray has been started and it should ask for a confirmation. I'm going to hit confirm. And within a few seconds, you can see that I have potential users and their passwords. It happens to be password at 123. It could be anything. It could be admin at 123. It could be your organization's name at 123. It could be the user's birth date, which could be found by a simple social media search. Right? And this script is intelligent. The reason I say that is because none of these users will ever get locked out. Right? You can see here that the lockout threshold discovered is 10 login attempts. If you can recollect, in the initial phase when we did reconnaissance, we found the domain's password policy where we saw that the lockout threshold was 10. Right? So we designed the script in such a way to perform a password spray attack and to be careful to not lock out any user, thereby not raise a red flag within the organization. Right, pretty straightforward. As an end user, I can perform a password spray script. I can perform a password spray attack in just a few seconds, and privileges, none. I could be a standard user. Right, so that completes the second phase of the attack, which is weaponization and delivery. I could create a malicious Office macro. It could be an Excel document or a Word document, send it as a phishing email. Users will download it and malware is installed onto their systems. Or if I already have compromised access, or if I am an internal user who wants to wreak havoc on the organization, who wants to see what he or she is capable of, I can simply run a password spray script. Right? So the first step is reconnaissance. Second step is weaponization and delivery. And both satisfy both use cases as an external attacker and as an internal attacker. Number 3. We've gained the initial infection, right? Let's say the phishing email worked. Let's say the users downloaded the attachment and malware was installed, or the password spray script worked, and we have some kind of access to the domain, right? What would be the third step? So if I were an internal user, this is how I would conduct an exploitation attack. Let me quickly show you right here. If I open up my PowerShell console, you can see that I have a script called power up right here, right? Again, a simple script that we made up. It's freely available over the internet. Now, what does the script do? Let me open up Windows PowerShell, right? Let me increase the size so you can see this properly. Now, CD desktop, just shifting to the desktop. And now PowerShell.exe-exec, and then bypass a simple command again to basically bypass execution policies. And now import module / the power up module that I just showed you. Right now, bear in mind that this attack is being performed by an internal user, right? So this is how it's going to work. PowerUp.ps1. And I will run a command called invoke all checks. So when I do this, what's going to happen is Ross's privileges are checked for in the domain, right? Anywhere Ross may have administrative privileges or privileges that can be escalated, right? For instance, privileges on services, privileges on unattended installed files, privileges that Ross may have gotten via registry or via the GPO, right? So once that's done, I'm going to run a command called write user add MSI. And once I click enter, here's what's going to happen, right? Just give this a few seconds. And what this does is it writes an MSI application to the desktop, right? An MSI application such as this. This application right here was dropped by the PowerUp script. Now what do we do? If I run the application, here I have the application, and now I'm going to call it attacker was here, right? A very conspicuous name. So once I given the name, specify the group, hit create, you can see that it's closed, but let me show you what just happened here. If I run net local group administrators, you can now see that the attacker was added to the administrators group in Active Directory. Right, so this is the third phase of the cyber kill chain. Initial phase was reconnaissance. Second phase was a simple password spray attack. And once I have some kind of access on the domain, I try to escalate privileges. How? By adding a backdoor user to a group of my choice, a privileged group or an administrators group within Active Directory. Right, this is how straightforward it is to add a backdoor user using PowerShell. Now this, bear in mind, was using an internal user's privileges, right? What if the user was external? Like I said, if the user was external, let me illustrate this using a quick example, right? So we sent the malicious document in the start to the end user. So the end user downloaded the attachment from the email thinking there's something interesting or something useful in it. And when the user enabled the macros, a piece of code got added to the web browser of the user, to the user's web browser, right? This is just a small piece of Java code. Now, what this code does is it looks for an image, as you can see, a source file on this IP address, which is basically the attacker's system, right? So let me explain this quickly again. We've sent a malicious email, a spear phishing email as an attacker, as an external attacker to a user. User has downloaded the attachment, enabled the macros. The macro added a small piece of code to the web browser. The code has an image, right, that points to the attacker system, that is in the attacker system. And the attacker system has a network sniffer installed. So essentially, whenever the end user opens up his or her web browser, the password hashes of that user are dumped to the attacker system. Why? Because the attacker has a sniffer installed on his or her system, and the code is trying to look for an image on this IP address, which is obviously on the attacker system. Right? So this is how, as an external user, I can get a user's password hashes. Right? The cyber kill chain is now complete. We assumed both the scenarios. We started off as an internal user where we could perform reconnaissance, but just by running a few commands, right? Get AD default domain password policy, get members of groups, or we could simply download a tool from the internet that automates the entire process for us. As an external user, there are multiple open source tools. Like I showed you a tool called Multigo, email permutation tools that can help you basically figure out the usernames or the user email addresses of the organization. The second phase of the attack was a weaponization attack, right? So what did we do in the weaponization and exploitation attack? We basically conducted a password spray attack, assuming it's an internal user, or we sent a spear phishing email, right? So that closes the initial infection phase. Once the initial infection phase is closed, the next step was exploitation. How did we do that? As an end user who has access, who has a compromised user's account as an internal user, we ran a PowerUp script using which we were able to add a backdoor user to any group in Active Directory. But when it comes to an external user, we went back to the spear phishing scenario again, where we were able to get users' password hashes. So all the phases of the cyber attack, like you can see here, reconnaissance, weaponization by creating malicious doc or Excel documents, delivery, exploitation installation, where we were able to install the MSI application, was achieved just by using PowerShell. Again, a built-in tool that comes with every Windows system, right? So how do we stop this? You can just say, just block PowerShell. I'm done with this. I know what's happening here. PowerShell is capable of performing attacks. So let's just block PowerShell, right? But PowerShell can be blocked. That's right. You can use the app locker rules where you can simply ban PowerShell, right? So whenever you open it, it says the app has been blocked by your administrator, which could mitigate most attacks. But then again, PowerShell is just an application, right? PowerShell.exe is simply a process that hosts this particular DLL, which is the core of PowerShell. So if you block PowerShell, only the application is blocked, not the DLL. So I could use the DLL to create a custom PowerShell console, right? I could launch a PowerShell under any other shell that I want, even though the actual application was blocked, right? So blocking PowerShell does not address the problem because, as you can see here, process name PowerShell, which we blocked, right? So I could still launch PowerShell under another process. Or I could simply download a PowerShell MSI from the internet and run this command to bypass any app locker whitelisting rules and run PowerShell anyway, right? So blocking PowerShell.exe does not address the problem because the core of PowerShell is this particular DLL, which can be abused to open PowerShell regardless of whether it's blocked or not. Other native monitoring tools, Microsoft did offer other monitoring tools like the constraint language mode, right? So when you use constraint language mode, you cannot execute malicious scripts. But the problem with this is you cannot execute any script. So if your services or your application use PowerShell for some reason, they will not work because constraint language mode is too constrained, right? It blocks most PowerShell scripts or most PowerShell processes. It blocks the necessary functions that are needed by your operating system or by your developers or by your applications that may use PowerShell. PowerShell introduced something called the anti-malware scan interface, or the AMSI, which can also be bypassed with minor changes in code, right? AMSI was introduced so malicious PowerShell scripts cannot be executed. But just by changing a few lines in the code, you can bypass AMSI. So your app locker rules fail, your GPO rules, so your software restriction policies fail, constraint language mode, which is used to block running PowerShell scripts, fails, and your anti-malware scan interface, which was introduced to block malicious PowerShell applications, also fail. So how do you audit malicious PowerShell? Windows logs are irreplaceable to audit PowerShell activities. So all you have to do is head into computer configuration, admin templates, Windows components, Windows PowerShell, and enable these two settings, module logging and script block logging. So what do they do? Module logging basically logs any command run by our PowerShell. For example, set execution policy bypass, which we initially did, right? That can be logged by module logging. Get something, invoke something, set master boot record, which is basically most COVID-19 based ransomwares do, to reset the system's boot record, right? Any commands such as set, get, invoke, outright that are run by PowerShell by your users are logged with module logging. And next up is script block logging. Script block logging basically logs entire script blocks. As you can see, this is an entire piece of code, right? Function get observation window. This entire code block is logged by script block logging. So these two can help you audit malicious PowerShell attempts. But there is a problem with native PowerShell auditing as well. There are a large number of logs generated, right? For a simple brute force attack, there are more than 100 logs generated. Users may use PowerShell for legitimate reasons. Applications or services in your organization may use PowerShell for legitimate reasons. There are no granular search capabilities with PowerShell logging, right? So you open up your event viewer, you cannot search based on certain parameters, such as a command that was invoked, a script that was invoked, right? Or a particular code block, like you can see right here. There are no alerts upon malicious PowerShell use. So if an end user is abusing PowerShell to perform reconnaissance or a password spray attack or a privilege escalation attack, there are no alerts, and last but not the least, there is no mitigation action. So if I catch a user running a malicious PowerShell shell, what do I do? What's the next step? What is the remedial measure? What is the corrective action? That's something that can't be automated and that can't be built by native auditing as well, right? So that's a large number of logs. Users may use PowerShell for legitimate reasons, no granular search capabilities, no instant alerts when your users use PowerShell, and no corrective actions, just in case a malicious PowerShell activity or PowerShell abuse is detected. So AD Audit Plus can help you with that. So this is how AD Audit Plus can help, right? So if I head into AD Audit Plus, all you have to do is head into server audit right here. And we've got something called PowerShell auditing. Just click on PowerShell auditing, head into script block logging, right? This will help you find out all your users and the scripts they have run. For instance, Ross here is a marketing user. So he has no job running a PowerShell script, but why did he do so? I can find out details about the PowerShell script, right? Any password spray script, any privilege escalation script that was used, you can find out details right here, right? You can also search for particular users. For instance, I want to search for all the scripts run by Ross, right? Here we go, the script name, powerup.ps1, here's the path of the script, and this is the potential data that was in the script, right? Obfuscated data, which must be alerted, right? Script block logging basically logs entirety of script blocks. For instance, write user add MSI, right? So this is a script block to basically add an MSI application. So this logs complete code blocks, and module logging, like I said, logs command invocations. For instance, if I search for Ross right here, you can find out Ross, right? And all the commands that are run by Ross, out default, write verbose, import module. Why is Ross importing a module in the first place, right? And why was this command run? PowerShell does exec bypass. Why did Ross have to bypass PowerShell execution policies? So these two options right here, script block logging and module logging, can help you determine everything about PowerShell scripts that you need, be it complete code blocks, complete function blocks, or individual modules executed, right? So once you find out what's wrong, once you find out potential malicious scripts that could be run, you can head into configuration, create an alert profile, right? I'm just going to call this PowerShell Audit right here. And I am going to select a PowerShell script. So let's just call it PowerShell Audit. Here we go, select the report, and you can set up a threshold, right? So for instance, if there are more than 10 recon attempts that are run by a user, or if there are more than 10 users being accessed by a potential password spray script within just a minute, and the user happens to be Ross, simply alert the administrator via email, via SMS, right? If users are running PowerShell scripts post business hours, simply alert the user via email or via SMS. If you wish to filter that more, for instance, I can add a filter and filter this more based on specific script data as well. If I have a piece of malicious code, or if I have a famously used PowerShell attack script, I can add that script right here as a filter, right? So whenever the script is run, let me quickly show you. Add filter, I'm going to call it script data, right? And I can add in a command invoked as well. For instance, command invoked set execution policy bypass. This is something that has to be monitored. Script data, any piece of a script that has malicious data, you can set it up right here, and you can alert the user via email, via SMS, you can alert the administrator, you can alert the authorized users, and not just that, you can execute a script as well. What does the script do? If it finds out that your user is trying to bypass execution policies, or import a PowerShell script, or execute a PowerShell script, or run a malicious PowerShell script, right? If it finds out, it will not only alert the authorized user or administrator, but also execute a script, right? All you have to do is simply write a script here that will disable the user's account or log out the user from his or her system, right? So that's how AD Audit Plus can help. Here you can see. Here's how we can detect reconnaissance attempts with PowerShell, where there is an alert immediately pushed onto the dashboard saying probable enumeration, and the user receives an email as well. And there is a remedial action that blocks the attacker, that disables the attacker, that logs off the attacker from his or her system. You can detect password spray attacks with PowerShell, as you can see right here. You can find out which user ran it. You can find out the content within the script, and you can get complete script details as well, right? The username, the path, the script details, set up an alert, you're good to go. PowerShell is not just capable of running attacks on your on-premises, but also your Exchange environments and your Azure Active Directory as well. For instance, a similar password spray attack could be conducted on your Azure Active Directory, and PowerShell can help detect that as well, right? Because we have a feature here called, if I head into reports, we have a feature here called user logon reports, right? So these logon reports are really helpful for you to find out any potential password spray or brute force attacks that could be run via PowerShell. Be it on-premise Active Directory or Azure AD, you can find that out right here, right? You don't even have to head into the PowerShell module and check which script is being executed. These reports will help you with that, the logon reports, right? Now, attacks, like I said, are not always this complex, right? It starts off with small mistakes that go ignored, that go unnoticed by administrators because, well, administrators have a lot of work to do. Who are we kidding, right? So it's important to detect certain crucial telltale signs. For instance, enter PS session. This is a command to enter a remote session onto another system. If an end user is running it, why is he or she running it? This is a command to bypass execution policies. Like I said, to execute any script that the user wants. Why is the user running it? This is a command to basically downgrade PowerShell. Why would a user downgrade PowerShell? Lesser security features, right? So if I run PowerShell with version 2.0, all my auditing features, all the script log and module logging would fail, right? So there would be nothing, there wouldn't be anything logged in the first place. So if there is a downgrade attempt, that should be alerted immediately as well. And if there are third-party tools like Mimikatz being installed or executed, that has to be alerted as well, right? And AD Audit Plus can do that for you. Simply search for the script, simply search for the user, the command invoked, the data inside the script, set up an alert, alert yourself, alert the administrators of your organization via email, via SMS, and also run a remedial action, a corrective action that will basically stop the user from doing further damage, disable the user, log off the user from his or her system. Now, it's no secret that PowerShell is a widely used tool for fileless attacks or malware-free attacks, and most antiviruses are not equipped to deal with PowerShell attacks. So it's time we ready our defenses. Adopt AD Audit Plus, set up PowerShell alerts, and you'll be good to go.